8.4, multiplying and dividing rational expressions. We're going to be using the rules that we used when we multiplied and divide fractions in this section. So those things will apply. And then simplifying. This one's not a very difficult section. I probably think that you'll like this one compared to adding and subtracting. Gets a little bit more complicated, but this section should be pretty good. All right, let's get started. All right, so when we are talking about this, we are going to be talking about excluded values or restrictions on the domain. And we talked about that last section, 8.3, with the asymptotes and the wholes and all that stuff. Those values that make that denominator, whoops, I spelled that wrong. That should be a DE, denominator equal to 0 or undefined. That just bothers me. I'm going to change that now. That just denominator. All right, that makes the denominator equal to or 0 or undefined. Recall, vertical asymptotes and wholes will restrict the domain. So the first thing we're going to do is we're going to find the excluded values. All right, so you want to simplify this first. All right, so 45 divided by 20, if you simplify that, that will become what? Whoa, my paper and everything got shifted. Hang on. Falling apart here, falling apart. There you go. All right, 45 divided by 20, which simplifies, will be 9 over 4. All right, and then m divided by nothing, the m stays the same. In 3 and in 7, you subtract them, and the number is going to be landing on the bottom because that 7 is the biggest number. So 3 minus 7 makes it a negative 4, which makes it land on the bottom to become positive. All right, so now the excluded values is anything that would make that denominator 0. If I put a 0 in here, that would make all of this equal to 0. So the domain would be all real numbers, but n cannot equal 0. That is an excluded value. Okay? Domain is all reals but that. Okay? All right, on the second example, we have a factoring problem that we need to simplify first. So I can take an x out of the top, and that'll leave me with x minus 5. On the bottom, that is a difference of squares. Okay, this is perfect, and there's a subtraction in between, so you should know that pattern breaks down to plus or minus. It's the only way you can get a negative in your answer, plus and a minus. Take square root of x squared and the square root of 25, and that breaks down to this. Same exact thing, but one's positive, one negative. That's the only way you can get a binomial with a difference. All right, from there you're going to simplify. All right, the x minus 5 and the x minus 5, they cancel. Okay, do you remember what that was called? That's called a whole, so those are gone. All right, and so then you're going to say, okay, what do I have left over? I have an x over x plus 5. All right, the excluded values are going to be anything that made this denominator 0. So x cannot be 5 or negative 5, because both of those would make the denominator 0. So that means that the domain is all reals except x cannot be 5 or negative 5. There was a vertical asymptote at, let's put that on here, VA, whatever's left on the bottom, so that would be a vertical asymptote at x is equal to negative 5. We had a horizontal asymptote the same degrees. There's a 1 in front of each, so then that would mean a horizontal asymptote at y is equal to 1. And let's see, what else can we do? We found a hole at x equals 5. And I think that covers it all. Okay, so this is our final answer. And then we can discuss all these excluded values right here. And then this is exactly what makes them. Okay? All right, so that is just simplifying rationals. Let's go on to multiplying. When we're multiplying rational expressions, you're going to factor them, cancel out. And remember, when you are canceling out or simplifying, you can only cancel out vertically or diagonally. Okay, you cannot do it horizontally. All right, so let's go ahead and look at this. This says 8x divided by 21y cubed. And then this one is 7y squared divided by 16x cubed. I want to make sure I was reading those numbers right. All right, so you're wanting to simplify these. Now, remember, you can cross reduce. So I'm looking across here, and there's the 8 and there's the 16. I'm going to cross reduce, and I'm going to make, because 8 will go into both of those, I'm going to divide 8 out. So divide an 8, and that'll give you a 1. Divide that 16 by 8, and you'll get a 2. That x and that x cubed will also divide out. I can take an x out of both, so that's completely gone. And then this will make this x squared. All right, looking sideways this way, I can see that 7 will divide into both of these. So 7 divided by 7 is 1. 21 divided by 7 is 3. I also have a y squared and a y cubed, so I can take a y squared out of both of those. That leaves me with just y on the bottom. All right, then you multiply across the top. Okay, multiply across the top, and you'll get everything is gone except for the 1, so it's just 1 over, and then we have on the bottom 3 times 2, which is 6x squared y. That would be our simplified answer. Okay, and in order for there to be no problems on the domain cannot be, x cannot be 0. If x was 0, it would mess all this up. Or y would be 0, it would mess all that up. But this is our simplified answer. And let's do one where there's factoring. Alright, so now we have x squared minus 3x plus 2. So that is a type 1. So you need to go ahead and factor this. And as I do it in factor, I will mark out the original so that way I'm not confused as to what I've already done. Alright, factors of 2 that add to be 3. Well, it has a plus in the back. It means same sign. We look right here. They're both going to be negative. Split up your x's. Factors of 2 that add to be 3. Well, of course, that would be 2 and 1. So I'm going to mark through that. I've already done all that. This is a difference of squares, and we just did one a few minutes ago, so you should know that should be a positive and a negative. Take the square root of both of these, and that'll be 6. That's gone. This is already simplified, and let's do the last one. Factors of 6 that subtract to be 5, that means opposite signs. Subtract to be 5 would be 6 and 1, and 6 is biggest, so the 6 gets the plus. Alright, now we mark this out. Alright, so now we have this over this, this over this. So let's simplify that out. I can take an x minus 1 away. I can take a x plus 6 away. And I think that's all I can do. So what I'm left with is this x minus 2 and this x minus 6. You don't want to multiply them back out, leave them like that. And all that's left on the bottom is just x plus 2. Okay? And that is your simplest answer that you can come up with. Now, if you wanted to talk about restrictions, there would be several restrictions, but mostly when you're doing the multiplying and all that, they're not going to ask you to do all that. So this is your final answer, x minus 2 times x minus 6, all divided by x plus 2. Okay? That's multiplication. All right, now when you're dividing rational expressions, remember, we really can't divide fractions, so we change the division to multiplication, and we flip or take the reciprocal of the second fraction. And once that's done, you're going to factor and simplify. So let's go ahead and change this to multiplication. So that's going to be k minus 3 over k plus 1. I don't know if y'all can see that very well. Let's change that to yellow. K minus 3. That's a 3. K plus 1 times, and you flip this, so it's going to be 1 minus k squared over k squared minus 4k plus 3. All right, now we can factor. This is already in factored form. This is in factored form. This needs to be factored. That's a difference of squares. 1 minus k and 1 plus k. Okay? All right, and then this one is going to become, I'm going to put it over to the side right here because we need some more room. Signs are the same. They're both subtraction. Split your k's up. And then you say factors of 3 that add to be 4. Well, that would be 3 and 1. Alright, so this is gone. Alright, so now we have k minus 3 times whatever's on the top, and then k plus 1 times whatever's on the bottom. Alright, so let's see if we can reduce anything. We have a k minus 3 and a k minus 3. We have a k plus 1 and a k plus 1. Now, what am I left with is 1 minus k over k minus 1. Okay? It didn't matter that the positive 1 plus k was that way because the signs were the same. Okay, it's a positive k and it's positive 1. Didn't make any difference. But because we have subtraction right here and subtraction right here, it does make a difference. Because when you simplify this, you have a negative k and a positive k. If I want to flip this around so it looks like this, I need to take out a negative 1. And that'll make this a negative 1 plus k. Okay, all right, over k minus 1. And because of the symmetric property, I know I can flip that around. So it is now k minus 1, just like the bottom. Okay? And if you'll notice, now I can cancel those, and my answer ends up being just negative 1. After doing all that work, just negative 1. Okay? So whenever you need to flip your answers around, if it's, a negative thing going on, you need to flip it around. You have to take a negative out, okay? But if it was positive, you would not have to do that. All right, so my final answer on this one is negative 1. So we're going to be practicing more of these in class. If you have any problems with these, come see me. I think these will be easier for you. We'll do a lot of practice with this. See you in class.